Okay, so thank you very much for having me. So this is presentations in algebraic colimits of enriched monads. This is a joint work with Rory Lucian Wright at Brandon University in Manitoba, Canada. Okay, so let's begin. Oops. Okay. So signatures and presentations for monads and theories have been previously studied mainly in the context of locally presentable enriched categories. See, for example, these papers by Kelly and Power, also by Lack, and the recent Bork and Garner paper, Monads and Theories. So in this talk, we'll discuss recent work on developing a very general framework for such phenomena that subsumes a much wider class of enriched categories, including locally bounded enriched categories in the sense of recent work by myself and Lucian Wright, and the symmetric monado-closed pi categories of Bursa and Day. So first I'll begin by discussing subcategories of Arities. So a subcategory of Arities in a V category C is just a small, full, and dense sub-V category. And it is eleutheric in terminology introduced by Lucian Wright if every V functor from J to C has a left conic extension along J, which is also preserved by each of the representable V functors for objects of J. This entails that the category of V functors from J to C is equivalent to the category of so-called J-ary endofunctors on C, which are endofunctors that preserve left conic extensions along the subcategory of Arities. And we let monad sub J of C be the ordinary category of J-ary V monads on C, so V monads with underlying J-ary endofunctor. So we'll also need this notion of a factegory, which I'll now define. So a symmetric monodal closed factegory is a symmetric monodal closed category V equipped with an enriched factorization system in the sense defined by Lucian Wright and previously by Day and Kelly. So V is a closed factegory, then a V factegory is a V category C equipped with an enriched factorization system that is compatible with the given one on V, in the sense that for every object of C, the corresponding representable V functor preserves the right class, i.e. sends M morphisms to M morphisms. A V factegory C is then said to be co-complete if the V category is co-complete and has arbitrary, even large co-intersections of E morphisms. Okay, so also I'll now define this notion of boundedness of a V functor. So let C and D be co-complete V factegories and alpha a regular cardinal. So V functor F from C to D is said to be alpha bounded if for every alpha filter diagram in C, and every M cocone on it, so a cocone consisting of M morphisms, if the induced morphism from the colimit to C lies in the left class of C, then the induced morphism from the colimit of F after D also lies in E. So this can be seen as a factorization system theoretic variant of the notion of preserving alpha filtered colimits. So if C is an object of the V factegory C, then C is alpha bounded by definition if the corresponding representable V functor is alpha bounded. If J is a subcategory of Arities in a V factegory C, then J itself is alpha bounded if every object is alpha bounded. Okay, so now I'll discuss blanket assumptions under which all of our results will hold. So V is a complete and co-complete symmetric monodal closed factegory. C is a co-complete and co-tensored V factegory where either EM is proper or C is eco-well powered. And the subcategory of Arities is bounded and eleutheric. Okay, so now I'll give examples of subcategories of Arities that satisfy these assumptions. So the subcategory of arities of alpha presentable objects in a locally alpha presentable V category C over a locally alpha presentable closed category V. Here, the J-ary endofunctors are those that preserve alpha filtered colimits or have rank alpha in other common terminology. The subcategory of arities consisting of suitable phi presentable objects in a locally phi presentable V category for a class of weights phi, satisfying axiom A from the Lac-Rositzky paper Notions of Lavoie theory in a locally bounded and eco-well-powered closed category V. Here, the J-ary endofunctors are those that preserve so-called phi flat colimits. The subcategory of arities of just the unit object in any complete and co-complete symmetric monodal closed factegory V. Here, the J-ary endofunctors are just those of the form X tensor blank for X an object of V. The subcategory of arities of finite copowers of the unit object in any symmetric monodal closed pi category V in the sense of Bourse and Day. This includes any complete and co-complete Cartesian closed category. Here, the J-ary endofunctors are those that preserve so-called NV flat colimits, so colimits that commute with finite powers. And these include sifted colimits. Finally, any eleutherix subcategory of arities in a locally bounded V category C, in the sense of recent work by myself and Lucian Wright, over a locally bounded closed category V as originally defined by Kelly. Okay, so let J be a subcategory of arities. A J signature is just a functor from objects of J to C naught. And we have shown that we have a monadic forgetful functor from J-ary endofunctors to J signatures. Also, we've shown that the forgetful functor from J-ary monads to J-ary endofunctors is monadic as well. So if H is a J-ary endofunctor, then the forgetful functor from H algebras has a left adjoint, and the induced V monad is an algebraically free V monad on H. So the two V categories of algebras are isomorphic, and this V monad is J-ary. So therefore, this W has a left adjoint, and it follows that it is monadic. So let J be a subcategory of arities satisfying our blanket assumptions. Then a J presentation is a pair of J signature morphisms from a J signature gamma to the underlying J signature of the free J-ary monad on a J signature sigma. We can show that every J presentation P presents or generates a J-ary monad TP, i.e. that there is a co-equalizer diagram in the category of J-ary monads on C, whose vertex is TP, which is preserved by the semantics functor. If M is a small diagram of J-ary monads in C, then we'll write GM for the limit of alg after M op. This is just essentially the limit of the V categories of algebras in the slice category over C. And a colimit of J-ary monads is algebraic if it's preserved by the semantics functor. So we've shown that if M is a small diagram of J-ary monads, then this GM has a left adjoint, and the induced V monad is an algebraic colimit of M, which is also J-ary. So monad J at C has all small algebraic colimits, and therefore every J presentation generates a J-ary monad. And kind of somewhat conversely, using a result of Lac, we've shown that the forgetful functor from J-ary monads to J signatures is monadic, and therefore every J-ary monad has a J presentation. So finally, Lucian Wright and myself have shown that every locally bounded V category, or that if C is a locally bounded V category in our sense, over a locally bounded closed category V, then every subcategory of arities in C is bounded. So hence, all of our results hold for any eleutherix subcategory of arities in any locally bounded V category C over a locally bounded closed category V. So I'm almost out of time. I just have one last slide of conclusions, which I will not speak due to a lack of time, but thank you very much for listening and for watching. And if you have any questions, I will be available during the Q&A session. And also here is my email and website and some references. Okay, thank you.